Hi there. Thanks for joining us on another episode of Space Nuts. Great to have your company. My name is Andrew Dunkley, your host, and I hope you can stick around because we've got a jam-packed show. We're once again going to Mars because they've looked at some new evidence that does suggest Mars oceans may have been vast. That is really exciting news. We're also going to look at the fastest spinning asteroid yet discovered. This one's really in a spin. It's making everybody dizzy. And the evacuation of the International Space Station due to ill health. We'll see if we can get some news on that because that's actually happening as Fred and I are recording today. That's all coming up on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And he's back again to furnish us with his knowledge. He is Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. I was just doing a quick calculation there for a number that I want to use later in the chat.
Okay. Now, I need to apologise in advance because they're working across the road and I think they're using dynamite because it's pretty noisy. But hopefully it won't mess me up too much. I can hear it, but I don't know if it's coming through the system. It's got all sorts of filters, but some things you can't stop. Now, Fred, I did want to actually mention a couple of things before we start on our topics because I meant to do this last week for our first show back of the year, just to highlight some of the things that are coming up in 2026 that we can look forward to and that you and I will probably talk about. The Artemis 2 launch is slated. Whether or not it'll be delayed again remains to be seen, but that will see a crew doing a lap around the moon, and that'll be the first time humans have been back in orbit around the moon since the 70s, which is exciting and probably too long, but that'll be good. This one I know will excite you. The Grace Roman Space Telescope is going to be launched. That one is going to open so many doors for us, I suspect. The Plato mission, which will be searching for rocky planets. It'll be doing a lot more than that, but that's one of the things that it's being set out to do. China is to launch its own space telescope as well in the hunt for dark matter and dark energy. And there's another mission that's going to be studying the moon and Mars, well, several missions, not just one, more Chinese and Japanese missions involved there. And I think this is one you and I have talked about before, the SMILE mission, which will be studying Earth's magnetic field and how the sun interacts with our atmosphere, is due to be launched this year as well. I'm sure there's a lot more going on than that, but there's some of the highlights of 2026. So we'll have a lot to talk about, Fred.
Could I add a couple more as well?
Oh, go for it.
We've just heard that the Pandora spacecraft has entered orbit, which I think is a spacecraft, again, looking at exoplanets to try and sort of tell us a bit more about how their atmospheres might reveal stuff. China has just filed for 200,000 satellites constellation with the International Telecommunications Union.
Oh, no.
Which is, well, it's not the biggest yet. The biggest was back in 2020 when the Rwandan government filed for over 300,000. Since then, they've launched one CubeSat, I think. So that looked like a filing that was more getting your foot in the door. And just turning to nature, we've got some interesting events coming up. March the 3rd, total eclipse of the moon, visible certainly from our hemisphere in Australia. Not sure about North America and Europe. There's towards the end of the year, and this will happen twice, which is great because you can see it on different sides of the Earth. I think it's October, sometime in October and sometime in November, there will be an occultation of the planet Jupiter by the moon. That means the moon will pass in front of Jupiter. And certainly for us in November here in Australia, it will be during the daytime. So get your binoculars out during the daytime, check out the moon and watch for Jupiter disappearing.
Oh, that'll be good. That'd be a good one for a backyard telescope, wouldn't it?
Absolutely. Perfect.
Yeah.
Yes.
Awesome.
Yeah.
I had my 6-year-old granddaughter here the other day, and the moon was out in the east, and it was still daytime, but it was pretty prominent. So I grabbed the telescope and gave her a look, and I tried to explain to her what craters were, and she struggled with the concept, but she eventually, I think, figured it out. But I took a couple of photos of her looking through the telescope. She was very excited. So,
which you sent to me. Fun. It was lovely to see them, Andrew. Yeah, lovely shots. A youngster looking through a telescope with Grandad in the background is great.
Yeah. She's got blonde hair and blue eyes, and her brothers and sisters are all brown-haired and brown-eyed. So she seems to have picked up Judy's side of the family genes because Judy's blonde with blue eyes. But she's the only one in the family that's gone that way. It happens, though, doesn't it? It's just the way it is.
Yeah,
That's DNA. Okay, Fred, let's get stuck into it, because we're heading off to Mars, and we're doing this because of a study that's just been published, in fact, in the last week or two, about observations of Mars that suggest that its oceans were once vast. Now, we always knew there was probably surface water, but we didn't really know whether they were, pockets or separate oceans or what. But now they're thinking the oceans might have been enormous.
Yes, that's right. And I mean, we revisit this story probably on average once every month or two. The last time we covered this, and I wrote it up actually in an Australian Geographic article. Not that I did the research, but this is other people's research, and that was pointing in the same direction, Andrew. It was a group that looked at the way ancient rivers on Mars meandered, because you can learn something from the meandering about the size of the body of water that they're emptying into. And they came to the same conclusion. The river meanders tell you that there was a large body of water at the end of it, at the mouth of these rivers, rather than just a few puddles or a few lakes and things of that sort. And this new piece of work, whilst it's a different, it's got a different emphasis, comes up with exactly the same answer. And it's scientists who have looked at if I remember rightly, they're in Switzerland, University of Bern. It's scientists who have looked at the region around Valles Marinaris, that great, huge chasm in the surface of Mars, near Mars's equator, something that makes the Grand Canyon look like a bit of a scratch on the surface of the Earth.
Yeah, is it right that the Grand Canyon would fit into one of its tributaries or something?
No, that's right. I think that's correct. Yeah,
amazing.
So they've been looking in that region, and certainly on the northern side and the northern flanks, there are valleys that sort of open out onto the plains of Mars, because that Valles Marinaris is kind of right at the start of the highland areas of the southern hemisphere of Mars. Mars has got this dichotomy: the northern hemisphere is flat and low, southern hemisphere 3 kilometers higher on average, full of craters, mountains, and all the rest of it. So what they've done is they've looked at regions where where there's this transition from the mountainous highlands of the south to the lowlands of the north. And they've looked very carefully at data from several orbiting spacecraft. I guess Mars Reconnaissance Orbiter is one, and some of the other ones. Actually, even ESO's ExoMars Trace Gas Orbiter. Mars Express, another ESA, European Space Agency, another orbiting spacecraft. They've taken the data from these, looked at the heights, the topography, and looked at the geomorphological features that they can find. What have they spotted? They've spotted a whole succession of ancient river deltas. This is to say regions where a river mouth opened into what they're calling now an ocean, and deposited its sediments. The sediments out of the river fall down to the floor of the ocean and build up basically a rock form, which is preserved today. It's a kind of fossilized river delta. There's something similar going on, as you and I have spoken about many times, at Jezero Crater, which is why Perseverance is there, because there's a river delta there. But I think these are on a much larger scale. And the great thing is that when you look at them, they sort of define a shoreline, because these are all occurring at the same topographical height in Mars's geography, and so they basically define a shoreline, and that shoreline tells you that there would have been a lot of water in Mars's northern hemisphere for the water level to reach the height that we find those deltas at.
Wow.
So really nice piece of work done with characteristic Swiss precision, I think, that's been widely reported. There's several articles on the science news feeds, which basically support this idea. Very nice piece of research indeed.
And they think it was as big as the Arctic Ocean on Earth, just by comparison. And how big is the Arctic Ocean? It's 14 million square kilometres, or 5.5 million square miles.
Big
in size. So that's a lot of water on Mars, and it's a lot of it's still there, Fred.
Yeah, that's right. With we know from particularly the Phoenix mission that just scraped the surface in the Martian Arctic, and sure enough, there was permafrost underneath. So a lot of it's still there. There's still water locked up in the two ice caps of Mars, but probably not. Well, I don't know. It's actually really interesting. I do remember reading quite some time ago that if you thawed out even just the Antarctic ice cap of Mars, you'd cover the whole planet to a depth of several meters. Now, whether that still holds good with what we've discovered since then, that was quite an old, I think that was probably 15 years ago, so that comment was made. It would be interesting to know how we evaluate that now. But I think it's still true that a lot of that water is still there.
Yeah. It is a fascinating story.
Water means life.
Yes, well, yes, we've said that many times, and you just don't know, do you?
You don't. Yeah.
Although the mission to retrieve those cylinders that contain potential evidence of that has been scotched, so it's just going to sit in abeyance for an indefinite period. So
I think. So this is news that the Senate have basically agreed with the White House in saying that the Mars sample return mission should be cancelled. And so that will probably go through. It's not been voted on yet, I don't think. But and so that means, yes, we've got these canisters on Mars, carefully dropped by Perseverance, but with a joint European Space Agency NASA mission to retrieve them, whose cost has blown out. We've talked about this before, and not perhaps surprising that it's now had a line drawn under it. Now that's bad news, because we really would like to get hold of these samples. There's one in particular that may contain actually fossilized microbes. So it's there's every keenness to do that, and I think it will. There'll certainly be a revisiting of this idea. ESA, I think, is still going ahead with their half of the bargain, which was, I think, to build the orbiter, which would actually bring the samples back to Mars. NASA's part was gathering them up on the surface and sending them up to orbit around Mars. It's bad news. There's a bright side to it, though, in that the money that's being saved will probably go to some of the other missions that are being planned. So name your favourite planet, you might get some good news out of this. I know your favourite, and probably mine too, is Mars. But anyway, we'll see what happens. I wouldn't write the Mars sample return off altogether. In my flights of fantasy last night, while my respiratory tract infection was making me cough all night, I was thinking maybe the Chinese could bring them back. Because I think they're planning a sample return mission as well. So maybe we do a deal there, which would be fabulous international cooperation.
It would indeed. Of course, we could always start the conspiracy and say, what does NASA and the US government know that they're not telling us? hence no
dear.
return.
Yeah. Be careful what you say, Andrew.
Look, I'm just kidding around, but it's just money, isn't it? That's the thing.
It's all about money. That's right. It's not about finding something with legs that you don't want anybody to know about.
Yes, that's been done in a lot of science fiction films.
Yeah, it has. Yes.
All right. Great story about the oceans of Mars, though. If you'd like to check it out, it's on the phys.org website, or you can read the paper that's been published in the journal NPJ Space Exploration. This is Space Nuts with Andrew Dunkley and Professor Fred Watson.
Roger, you're loud and clear here also.
Space Nuts.
To our next story, Fred, and this is a really good one for a couple of reasons. It's something we haven't seen before, but it also involves the Rubin Observatory, which has already done things that other observatories have not been able to do and promises to do so much more. This is the fastest spinning asteroid yet discovered, and a couple of headlines I've read suggested why hasn't it thrown itself to pieces because of the speed at which it's rotating. And the rate is rather high when you look at what the average asteroid does.
Yeah, it's so it is a record breaker. It's the fastest spinning asteroid for its size,
right?
Because I think smaller things can spin faster than this. It's 710 meters long, nearly 3/4 of a kilometer. So it's not a small asteroid at all. This is quite a large one. And it spins at the rate of one rotation every 1 minute, 53 seconds. So that is one heck of a spin. So that's its day length, Andrew. If you were standing on it, your day will be 1 minute, 53 seconds, night and day, not 24 hours. No. But you're right. You're absolutely right. I think it's interesting for two reasons. One is exactly as you've said. It underlines just how powerful the Rubin Observatory is going to be. The observations of this object were made during the sort of commissioning period for the telescope's instruments, which was earlier last year, April and May 2025, and that. As you probably remember, I think they released information saying they discovered more than 1,000 asteroids in 10 hours of observing, which is pretty fantastic. The telescope's capabilities will allow it to survey the entire southern sky every 3 nights. With an 8-meter class telescope, that is an astonishing achievement. And
we must find something incredible.
Yeah, we will. There's going to be all kinds of things that come out of the woodwork. It's what we call sort of time-sensitive astronomy or transient astronomy. You're looking for things that either move or change in the sky, and it's going to be so good at finding them. And so the real observing campaign, the Large Synoptic Survey, will start sometime this year, sort of when they're ready to hit the go button. But I think everybody at the Rubin is pretty happy with the way things are going. And just to sort of highlight that, it's a telescope with this kind of capability to make many observations over a short period of time of the same area of sky that has allowed the scientists to discover the very rapid rotation of this asteroid. Because what you have to produce to look at the way an asteroid rotates is what's called a light curve. You look at the way its brightness changes because most asteroids are quite asymmetric. They're either shaped like a potato or a dumbbell. Very few are anything remotely spherical. This particular one is, I think, quite elongated. And so as it rotates, different sides of it catch the sunlight, and you get a variation in the light that we see from it. And so that has allowed, because it's only 1 minute 53 seconds for one complete revolution, that has allowed the scientists to determine that fact. So to the asteroid itself, you're right, it's interesting. It rejoices in the name of 2025 MN45, a classic asteroid name. And it's in the main asteroid belt. That's a good place for it to be between Jupiter and Mars, where most of the asteroids are. But its rotation is what highlights the unusual nature of it. Because as you and I have spoken about before, many asteroids are basically what we call rubble piles. They're just piles of debris which stick together loosely under their own gravity. Little Dimorphos and Didymos, the two objects that NASA did the DART test on a few years ago, they are probably rubble piles. They've got the characteristic rubble pile shape, which is like two cones on back to back. This, if it was a rubble pile, it would have flown apart gazillions of years ago with that short period of rotation, 1 minute 53 seconds. So and when you look at the size of it and interpret what the rotation means, it tells you it's probably made of absolutely solid rock. This is something that is going to be hard to pull apart to rotate, for it to be that big, rotate at that speed. It's got to be solid rock, making it, in some ways even more interesting, because we think the rubble piles are perhaps the more common asteroids that we see.
Do we have any idea what would make it different? Why it would be different? Is it a piece of a destroyed planet, Theia?
Well, yeah, could be. Might be part of Theia, the one that created the moon after it collided with the Earth. It's more likely. You're right. It's probably maybe part of the outer mantle of what would have been a protoplanet in the early solar system. These things were the building blocks of planets. They collided, and sometimes they blasted each other apart. Sometimes they stuck together to form what we see in the solar system today. And I think some of the collisions that would have happened in the early solar system may well have set an object like this spinning very rapidly. In fact, it might have, initially been spinning even more rapidly than it is now, because we're looking at probably several billion years ago when whatever happened to it happened. So an object of some interest, and one that I'm sure will be studied in greater detail. We might want to know things like, the infrared signature of its surface, which gives you an idea of what the surface is like, how rough it is, whether it's a smooth surface, what materials are likely to be found on its surface. That can all come from spectroscopy, and also the science of polarimetry, which is what you look at to know whether something's highly reflective or rather rough and diffuse. So I think there's lots to learn about 2025 MN45.
Indeed. So it's in the asteroid belt between Mars and Jupiter. People probably imagine that to be just a wall of rocks. How do we get through it? But it's quite sparse, isn't it?
It is, yeah. It's sparse enough that several spacecraft have actually gone through it unscathed. So yes, it's.
Well, I've never heard of a spacecraft actually running into anything out there. Not that there've been that many that have gone through, but
that's right. But as was it Douglas Adams? Space is big. Yes. You might think it's a long way down to the chemist at the corner of the street, but that's nothing compared with space. I think that was what he said.
Yes, indeed. So if you would like to learn more about what the Vera C. Rubin Observatory has discovered, you can do that at the universitytoday.com website, or you can read the paper in the Astrophysical Journal Letters, which was only published on January the 7th. So they're getting down to business early this year, aren't they? This is Space Nuts with... Sorry,
I was just going to say, we always get a really good crop of news stories at this time of year, because it's right at the beginning of January that the American Astronomical Society has its annual meeting. So there's always some great stories. So that's why it was it was published last week. I'm sure that's
it's actually very clever, because as someone who worked in the media for 40 years and had to work a lot of Christmases and New Years, you quite often find you're struggling for stories, because everything's shut down, so you're not getting the information that you normally get. So to actually be in a position to do stories like this at this time of year is And it's well positioned, as we would say. You can read all about it, of course, and we will certainly be keeping a very close eye on what the Vera C. Rubin Observatory is going to be doing from now on, because it's all up and running and already doing some remarkable things. This is Space Nuts with Andrew Dunkley and Fred Watson.
0G, and I feel fine.
Space Nuts. Now, Fred, by the time people hear us talking about this story, things will have changed a bit. But as we speak, we understand that the Crew Dragon spacecraft is docking at the International Space Station to do the first ever crew evacuation. Now, after 25 years, I'm surprised this is the first time this has happened, but there's been a medical issue. They won't elaborate on who or what, but it's got to be serious if somebody's, if they're bringing the whole crew back. It's a crew of 4. There's 7 on board at the moment, but they're bringing 4 back.
Correct, that's right. So there is a crew of 3 now. So as we speak, I think they've probably undocked the Crew Dragon spacecraft from the International Space Station. I think that happened an hour ago. And they will then re-enter and bring the crew back in a pretty routine fashion, landing in a few hours from now. So you're right, it's Crew 11, the SpaceX what's called the SpaceX Crew 11, because they're the ones that go up and down in the Crew Dragon, rather than the Soyuz, which is the space vehicle that will bring the remaining 3 astronauts down when their time comes to an end. You're right, it's a medical evacuation. That Crew 11, consists of, if I remember rightly, 2 NASA astronauts, 1 Russian cosmonaut, and a Japanese astronaut as well. So they're coming home. They're coming home something like a month early, and we are told, exactly as you've said, that this is because of a medical issue, which apparently is not an emergency. It's not urgent, but is thought to be something that is going to be much better dealt with on Earth. We don't know which of the astronauts has the issue. I saw a picture of them posed just before they evacuated the spacecraft last night, and they all looked fairly cheerful. But you can't really read from people's faces how they're feeling, which is just as well, because I feel pretty crook at the moment.
Yeah.
So that's because of my upper respiratory tract infection. Sorry to keep harping on about it. Anyway, going back to the more important story, Andrew.
It's a good thing you're not in the International Space Station feeling like that.
Well, that's right. Else you'd have the same thing too. Interesting. But your comment's well made. The fact that it's the first time in the 25-year history of the ISS being permanently occupied, the first time this has happened. And I think it was Jared Isaacman, the newly appointed NASA administrator, the boss of NASA, who made the comment. It might be somebody else, but it's one of the high ups in NASA made the comment that when they planned the ISS and they were working towards it, they expected that there would be something like this happening every 3 years. So they've done pretty well to get through 25 years without needing to bring people home because of a medical issue.
Yeah. While you've been talking, Fred, I've just been looking online to see where things are up to, and I've found they did a live stream of the Crew Dragon docking at the International Space Station through, I think it's NASA's YouTube channel. And you can actually log on and watch what happened and see the whole process. It's quite incredible what we can do now, isn't it, with live coverage from space as things unfold. It's a far cry from those times back in the 60s and 70s when we were looking at those really fuzzy black and white pictures off the moon.
Which was miraculous in its day.
Oh, it was in itself, yes.
Yeah.
I am watching Crew Dragon detach as we speak.
Yes, that's right.
So that happened probably 30 minutes ago, give or take, our time.
There you go.
Yeah. It's like a slow motion ballet, isn't it, when they
things in space tend to be like that.
Yes.
Yeah. Well, you don't want to bang into anything.
Yeah. Anyway, I hope all is well with the individual involved. I'm not sure we'll ever find out what exactly the issue is. That's subject to privacy, from what I understand.
Exactly.
But the fact that they've been able to go up there, get them, bring them back, and deal with the problem is extraordinary. Because go back to the 70s when Skylab was in orbit. If someone got sick or injured in that situation, I don't know if we would have been able to do much in a hurry.
Yeah, maybe not. I mean, there would have been contingency plans in place. I think some of the things that might have brought somebody home from Skylab might be things that could have been fixed on the International Space Station, because there is quite a fair amount of medical expertise up there and some of the kit. But you don't want people taking appendices out and things like that up in space.
No, not really. No. You just have to wipe down the walls afterwards, and that's
exactly.
not fun. Although I should counter it by saying we did recently have a situation where a crew got stuck on the International Space Station for very unusual reasons due to incompatible spacesuits because of a failure in the Boeing Starliner.
Yeah.
So, no, that wasn't a quick rescue, that one, but it didn't involve illness or injury, so it wasn't as urgent. But sometimes it can be a slow process. But but NASA's been very quick to point out that this has got nothing to do with an operational issue. It's a personal issue, nothing to do with an injury or accident on board. So they want to make that pretty clear. We wish them well. They're on their way back as we speak, and by the time you hear this podcast, they will have returned, no doubt. That's it, Fred. Well, gosh, we got through that in a mighty hurry, didn't we?
Yes, I think we gave it due recognition. We've been talking for well over an hour, Andrew.
Oh, have we?
Yeah.
Doesn't feel like it. But no.
No, we haven't. I beg your pardon. 38 minutes. I'm sorry. I'm misreading my clock. You're right.
That's okay.
Wow, we got through that in a hurry.
You're probably reading a Mars clock, because we talked about that recently. It's going a bit faster.
No.
Now, if you were to follow up those stories, I've told you where to go and look for them, but you can also read the show notes on our website, spacenutspodcast.com or spacenuts.io. And while you're there, you might like to check out all the tabs and links on our website, the Astronomy Daily feed. You can subscribe for your daily dose of astronomy and space science news. Don't forget reviews. We really do appreciate your reviews. The more reviews, the more we get noticed. And the more we get noticed, the more people listen, and then we can buy ourselves an ice cream at the end of the day. You can also send questions or comments in through the AMA link, and so on and so forth. And don't forget to visit the Space Nuts shop. That's one thing that Hugh did some years ago, and it's been very popular. All the Space Nuts memorabilia, if you want to get hold of it. I've got my Space Nuts cup here somewhere. Here it is. Look at this. There it is.
I never got one of those.
I had to buy it. No,
that'll be why.
That's good.
I'm too stingy.
But we got shirts. We've got hoodies. We've got all sorts of bits and bobs at the Space Nuts shop at our website. Thank you, Fred. We'll leave it there. We'll catch you on the next episode.
Look forward to it, Andrew. See you soon.
Professor Fred Watson, astronomer at large. And thanks to Hugh in the studio, who couldn't be with us today. He had to be evacuated after attempting a Michael Jackson moonwalk. Not good at his age, no. And from me, Andrew Dunkley, thanks for your company. We'll catch you on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.